Hello everyone, in the last video I have shown you the introduction to Etabs and in this video we will see how to analyze the portal frame. So click on file, click on new model. So let's use the second option, use settings from a model file. So click on OK. Now let's use the intro settings which I have shown you in the first video. The link is in the description. So click on open. Here for portal frame we need to have two grid lines in X direction and one grid line in Y direction, and the spacing in X direction, that is from one column to another column, let's keep it as 4 meters, and the spacings in Y direction, it doesn't matter as there is only one grid line in Y direction. Let's give the number of stories as 1. Click OK. Here you can see that two grid lines have been formed in the X direction and a story has been formed, as you can also see it in 3D view. So let's go to quick draw beam command and let's select the property which we have given, that is the beam 300 by 300. So let's go to elevation 1, apply, OK. Here you can see that this is the elevation 1. Let's now assign the properties. So go to quick draw beams. Now change the property, that is B300 by 300 if it's not into. So just select the grid line. Here you can see that the beam property has been assigned. Now the column properties have been logged. You can't use the column properties as you can't assign the column properties when in the front view. You can only assign the column properties in either 3-dimensional view or from the top view, that is the plan view. So let's go to plan. Let's go to story 1, apply, OK. Here is the story 1. So let's give the column properties. So click on column. So change the property, that is C300 by 300. And let's just give two columns, that is one at this point and another column at this point. Here you can see that two columns have been formed. So let's close this 3-dimensional view. Now let's come back again to the elevation, that is one elevation, apply, OK. Here is the elevation and all the properties have been assigned. So go to normal cursor. Now let's assign. Now let us assign the loadings. So select the beam, click on assign, click on frame loads, click on distributed load. So let's give a distributed load of 15 kilonewton per meter, and the direction is gravity, so you need not assign it as -15, and click on replace existing load. For the first load you need to give and click on apply and click OK. Here you can see that the 15 kilonewton per meter load has been assigned to the beam. Now if you want to again assign a point load, so select the beam again, go to assign, go to frame loads, go to point load. Let's give a point load at 0.5 meter distance, that is 0.5 into 4, that is half the weight. Here the loading value let us give as 10 kilonewton. So add to existing loads, click on apply, click on OK. Here you can also see that a point load has been assigned of 10 kilonewton. Now let us provide the supports. Now in Etabs, normally if you don't provide any support conditions, it by default takes it as hinge supports. So first select the joints, go to assign, go to joints, go to restraints. Here you have 4 types of restraints, that is one is fixed type, another is hinged, this is a roller condition. Now this is used for giving a free support condition. So let's select fixed supports, click on apply, click on OK. Here you can see that the fixed end has been formed. Now the property has been assigned, the loading has been given, the support conditions have been given. Let's go to analysis. So click on analyze. Now before analyzing the model, you need to check the model for any warnings. So just click on select deselect all and click on OK. Here dialog box pops up which shows model has been checked, no warning messages were generated. So there are no errors in the model we have created. So close it. Now run the analysis. So click on run analysis. Let's save it as portal frame. Click on save. Now the structure has been analyzed and this is the deformed shape of the portal frame. If you want to see the bending moment and the shear forces, so just click here the symbol. So M33 is the major bending moment, that is along x direction, whereas M22 is minor bending moment along y direction. Similarly the shear forces. So if you want to also view the values of the bending moment, so click on the show values and click apply, click OK. You can also check the values by moving your cursor. Now as fixed supports are given, you can see a bending moment has been produced at the fixed ends also. So let us check the shear force. This is the shear force diagram. As a point load has given, you can see that the variation of shear force from a general to a steep has been taken place. Let us see what happens if we change the support conditions to hinge type. So go to undeformed state. Now before you edit anything in this model, you need to unlock the model, because as soon as you run the analysis, the model gets logged and nothing can be edited in the model. So click on unlock. OK. Now let's select the two end supports. Go to assign, go to joint, go to restraints, go to hinge, apply. OK. You can see that the hinge supports have been formed. Now analyze the structure once again. Run analysis. This is the deformed shape. Now if you want to see the animation, you can just click on start animation. This is how the structure deforms. Click on stop animation. So let's check the bending moment and shear force values. So click on moment 33, apply, OK. Here you can see the value of the bending moment at the end support has been decreased to 0. This is because hinge supports do not carry any moment, whereas a fixed support carry a moment. So let's check the shear force diagram. Apply, OK. Here you can also see the shear force value has been decreased from 10 to -6. So if you want to create a structure with low value of shear force, you need to go for hinge support. So this is it with the portal frame design in Etabs. Thank you for watching. In the next video, I will be showing you analysis of the continuous beam. So please subscribe and hit the bell icon to get notified.